Checking the slide again, we'll configure bridge interface next. This is needed for LXC or Linux containers we'll deploy later. There's some foundational knowledge you'll need to understand this fully, and there's no way for me to cover everything here. My advice to you is to just follow along and fall back to ArchWiki whenever you hear something you don't understand. Before we start though, I'll try my best to explain what we are about to do and why through a quick drawing. This is where we are at the moment. We only have this one VPS, but at some point we'll add an LXC runtime. If you don't know what it is, it's an operating system level virtualization method for running Linux containers using the Linux kernel from the host. And that's precisely what we'll do, run some containers. This VPS has its own localhost address, and it also has a public IP address, in my case this one. The issue is those containers will need an IP address too, otherwise they won't be of any use to us. While there are multiple ways to achieve that, I like to use a so-called host bridge. That means that we'll create a new bridge interface and configure it so that the host OS and any container we create with LXC will get an IP address from the same private subnet. Let's say that that subnet is 10.100.100.1/24. If we assign .1 to our host and 111 and 112 to our containers, they can all communicate via this bridge interface without any additional routing configuration. We'll talk more about this after we actually deploy some containers, so if you're not quite getting this, don't worry. For configuring this bridge interface, I'll create a new file in tasks directory named br0.yml. To create a bridge interface named br0, we need two files, br0.netdev and br0.network. Using the Ansible's built-in copy module, we'll copy the file from our client machine in files directory over to the server to this location. We'll set some permissions, and since we are messing with the network configuration, we'll trigger a handler which will restart systemd networkd. I'll save this file and open br0.netdev in files directory. And this is all there is to it. You define a netdev by giving it a name and a kind. I'll save this one too and open br0.network also in files directory. We first need to match the device defined in .netdev, and then we assign an IP address range. You should pick a subnet that does not collide with your local network. This IP masquerade line requires another drawing. Using this host bridge, our containers will get IPs which are from the private subnet. In order for a container to be able to access the internet, we must mask its IP with the IP of the host. If we don't, when network packet from the container tries to reach something on the internet, it will have its return address set to this IP. And when it reaches its destination, the other side will not be able to reach back to this private IP. But with the IP masquerade line, our containers will hide behind VPS public IP. They will use it as a gateway, and this network packet will have its return address set to the public IP of our VPS. The other side can then reach back to it, and traffic can flow between containers and the rest of the world. There's one more thing needed for this to work, and that's the kernel's IP forward setting, but we'll deal with that in due time. Let's include this task in main.yml in tasks directory. So add another line, and this one is named br0.yml. Save it, and in virtual environment run Ansible playbook setup.yml. In the Ansible's output, we can see that br0 netdev and network were created and that handler was triggered. make sure that bridge interface is created by connecting to the VPS and running IPA. And if you don't see BR0 here in the list of interfaces, you might have to reboot your VPS using systemctl reboot.